Hello, everyone, and welcome to our presentation. My name is Elise Gray, and with me, I have Faith, Alyssa, and Lance. And our research, we were focused on monolingual and bilingual college students' performance on English and artificial Stroop tests. Starting with our introduction, we wanted to go over our topics of interest, and the first one that we were interested in is comparing the inhibitory control of monolingual and bilingual individuals, as well as seeing if the bilingual individuals had a code switching advantage, as well as seeing if there's a difference between language acquisition when looking at bilingual and monolingual individuals. Now going into our literature, Lance will take it away.
So literature on inhibition, a study done by Desjardins in 2018 showed that there was no significant difference in performance between monolingual and bilingual groups on visual tests of inhibition. And so from this study, as well as others, Blumfeld and Marian, in 2014, we decided to use a Stroop test in the present study. This is because bilingual individuals were shown to have better scores on the Stroop test, but no advantage on the Simon test, which was a different test used in the Desjardins study. In a study done by Hilbert in 2014, there was a heavy emphasis found on using a verbal Stroop test instead of a manual version, for example, on a computer.
We were also looking to see if there was a bilingual cognitive advantage within the literature. And from Hartanto Yang, we found that there was a significant difference between switching and inhibition of attention when looking at bilingual individuals compared to monolingual individuals. And we also saw some bilingual advantages, such as enhanced executive attention, task switching, and just various performance advantages when looking at different cognitive tests in general.
We were also interested in looking at instances in which there was no advantage. In a study done by Bialystok in 2009, there was no advantage, and in a study done by Donnelly in 2019, the cognitive advantage was weak. Due to this, we believe that it is controversial because some studies find evidence promoting it and some do not.
We also looked at literature regarding code switching and acquisition of language. With Emory, it showed a significant cost to turn off a language, so switching out, but no cost to turn on a language, so switching into. The results for the second study also showed that language transfer is helpful to the acquisition of a second language if the learner is aware of the similarities and differences between the two languages and willing to transfer the knowledge and skills of the first language to the second language learning. For the gaps in literature, the bilingual advantage was weakly supported, with not many results shown in the literature. It also seemed like more studies are needed to understand the bilingual advantage, as not a lot of research regarding the multi-layers of inhibition were found. In the study by Alteriba and Mathis, it was the only study that we know of that uses a Spanish Stroop test, but it was with one-word learning and color, compared to our study, which we used two languages, English and artificial, as well as color.
We had several unique contributions to our study, including strengthening the existing literature, using an artificial language in a Stroop test, using a learning period to learn that artificial language, and having the unique experience of being completely virtual due to the pandemic. Our purposes for wanting to look at this were to test whether bilingual individuals had a cognitive advantage and to show that these potential advantages could be attributed to the frequent use of code switching and inhibitory control.
When summing up all of this that we've just discussed, we wanted to put together a research question to kind of make sure our focus was correct going forward. And that question that we put together was, will bilingual individuals perform better on both English and artificial Stroop tests when looking at accuracy and response time because of their inhibitory control compared to monolingual individuals?
For our hypothesis, you can pause the video right now if you would like to read all of it, but in a nutshell, it was just that on all measured tests, bilingual individuals will have faster response times and greater accuracy scores. And now for our method section.
All the participants were recruited through the TLU psychology department, the Spanish department, and by word of mouth. We looked at students of college ages from both public and private universities around the ages of 18 to 25, with a total of 62 participants overall. They were all shown to be fluent in English from the LEAP-Q test. And shown here is our monolingual participants, in which we had 32 total, 5 males with 27 females. 4 participants from this group were excluded from our analysts because they're outliers in our data. As stated before, the participants were recruited from the college age populations of 18 to 25. With the participants in our bilingual group, we had 30 participants overall, with 24 being English as a first language, Spanish as a second, and 6 being Spanish as a first language, English as a second. They were all shown to be fluent in English through the LEAP-Q scores. There was only 1 participant in this group that was excluded from our analysts because they were outliers in the data. And Elise will be talking more about these outliers in the results section.
For our measures and stimuli, as mentioned by Alyssa, we used the LEAP-Q test to test language proficiency. And then we had congruent and incongruent English and artificial Stroop tests, as well as a learning period.
So these were the artificial words that we used. They were pronounced pretty phonetically: dite, stad, eater, jang, etc. We found these artificial words in the novel object and unusual name database. In an effort to be consistent, we chose words that were 4 letters long.
So now I'm going to show you how a trial was conducted after completing an online consent form and a LEAP-Q test. Participants would join a Zoom call with the researcher. They would start with the English activity. This is an example slide for the congruent test, so the color matches the spelling of the word. Once the participant understood how to do the test, we would move to this slide where the researcher would record accuracy and response times. Once this was complete, we would move to the incongruent English test where the color of the word does not match the spelling. So the word blue, the participant would have to say red. They would repeat this process as on the first test, and the researcher would record accuracy and response times. Once they completed the English activity, they would move to the foreign learning period.
In the foreign learning period, the participants had a chance to learn all of the foreign words, so in total 8 words. So what they would see is first, they would see the English word, and then we would pair it with the artificial, what they would know foreign word, and they would have to repeat this word back to us just to make sure that we know that they know how to pronounce it. And they would do the same process for all 8 words. And then once they learned all 8 of them, they had to do a verbal recall test. So this verbal recall test, the participants did not see this slide, and we would quiz them, and they would have to respond with the correct artificial word to the correct English word being asked. And they had to do this until they had 100% accuracy in order to move on to the next step of the research process.
Once they successfully completed the foreign learning period, we would move on to the foreign activity, which is the exact same format as the English activity. So with the only exception being, instead of saying the colors in English, they're saying the colors in the foreign language that they just learned. So once again, a congruent practice slide, followed by the congruent test where accuracy and response times were measured, followed by an incongruent practice slide. So for the first word, instead of saying fisp, the participant would say dite. And then again, the incongruent artificial test where accuracy and response times would be measured. After this, the participants were debriefed. Now for our results.
So these were the variables that we measured. Our only independent variable was language status, whether the participants were monolingual or bilingual. Our first 4 dependent variables were our controls. These were the congruent parts of the English and artificial language tests. The next 4 variables were measuring the incongruent tasks. We measured accuracy and response time for each of these. Accuracy was the percentage of words they got right, and response time was for how long it took them to get through all of the words. Dependent variables 9 and 10 were measuring the difference scores. The difference score was calculated by subtracting the incongruent task scores from the congruent task scores. We did this for both the English and artificial tasks.
So now going more in depth with our analysis, we used JAST and we did 3 one-way repeated measure ANOVAs. And just like Alyssa was mentioning in the participant section, we excluded some of the participants from our data due to them taking 5 or more times on the foreign learning period. But looking more specifically at this ANOVA, this one was for response time, and it had the independent variable of language status, just like the following will also have. And what we can see on this chart is that the reaction time, there was a significant mean effective test. There was also a significant interaction between reaction time and language status. And in order to look a little bit more into these results, we did a post hoc paired sample t-test, and we can look more closely on that in the graph in the next slide. So in this graph, this one is looking specifically at the chart that we were just looking at, and you can see that the artificial incongruent test was where that significant main effect was coming from. All of this is just saying that the bilingual individuals took a little bit longer compared to the monolingual individuals on this specific Stroop test. So now going on to our second one-way repeated measure ANOVA, this one is specifically looking at accuracy. And what we can see is that there was a significant main effective test with accuracy, but there was not an interaction this time with accuracy and language status. And so in order to look more closely at this main effective test, we also did a post hoc paired sample t-test. So on the next slide, when looking at this graph, we can see that both the English incongruent and artificial incongruent Stroop tests were the ones that were driving that interaction. And we can see that this is basically just saying that the incongruent test had lower accuracy compared to both the congruent tests. Now looking at this final one-way repeated measure ANOVA, this one is looking specifically at difference score, and we can see that there was a significant main effective test with the difference score, but something that was unique about this one was that there was a between group difference, which you can see on that second chart below on the between subjects effect chart. And so in order to look more closely into this, we did a post hoc independent sample t-test. So when looking specifically at this graph, because there was a significant between group difference, both the English and artificial tests were significant. So there was no need for notation on this graph. But what we can see here is that the artificial test, both monolingual and bilingual individuals took longer to complete these tests compared to the English test time. Now moving forward into our discussion.
So our findings were that participants were slower on the incongruent test compared to the congruent test, which supports studies done by Blumfeld and Marian as well as Hilbert. Participants were slower on the artificial test compared to English tests, and no bilingual advantage was found.
For our limitations, we wondered, even though we used the same script, if a pre-recorded audio could be used for more consistency. Also, because the researchers were of different sex, we wondered if that could be a possible extraneous variable, as we didn't use sex as an independent variable. With resources being limited due to the pandemic, there was also some difficulty in color interpretation due to the technology, since they was all done on different screens. An example of this would be the color pink could be misinterpreted as purple. We also wondered if there was a lack of long-term memory attention, as it could be a factor due to the lack of time between learning period and the recall test.
For future studies, you could look. The studies could look at bilinguals of different language backgrounds or even polyglots. They could also look at the difference between other variables such as sex, ethnicity, and level of education. This could also be replicated with different inhibitory tasks other than the Stroop, and participants could learn more than 8 words or be tested at a later date. And these are our references. Thank you so much for giving us your time. If you have any questions, please feel free to comment down below.